So you notice that reactive metal zinc is going into the solution as zinc ion, leaving the electron behind. So this electrode becomes negatively charged. Now at the same time, you notice this is less reactive metal, less reactive, less tendency to react. Very few, negligible atoms of it are going into the solution as ions. It means technically there are very less electrons. When there are very less electron, it has a high electrode potential, it has a low electrode potential. So to make things simpler, we term this electrode as positive. Positive nothing mean it has less electrons. Okay, it has low potential difference. It has low potential. So when you join these two terminals together, electrons find a pathway to move from high potential to low potential. So they start moving from high potential to low potential. In between your watch, in between your bulb, in between anything, receive energy from the electron and start working. So at cathode, basically at this electrode, an unwanted reaction normally occurs, that if a solution has positive ion, they may go there, and as electrons are coming there, they can accept electron, those ions can accept electron, and normally goes off as hydrogen gas if it is H positive ion present. There are certain depolarizing mixtures, you may not, like in your syllabus it may not be included, but certain depolarizing mixtures are there added to prevent this reaction. But to keep things simple, the cell work on the principle, you need a reactive substance and you need a least reactive substance. A reactive metal will go into the solution as ions, leaving the electrons behind, making this electrode as negatively charged. As a result, the other electrode is not doing the same thing. So high potential, low potential, sort of EMF, electromotive force generated, current start moving from negative terminal to positive. When the examiner asks you to show the direction of the current, then it means you show it the direction like this, drawing the arrows like this on the conductor, on the wire, not showing like this, that from this terminal to this terminal. It is wrong way, because electrons cannot move through the solution. They have to find the pathway through that, and in between they will light up your appliance, whatever it is. Okay, so this is one example, like zinc and copper. Now as copper is getting expensive, you will find out that these days we need only a conducting material. So when conductor is needed, only an inert electrode is needed. The cheapest of the option is you can break up any cell, normal cell, and you can find out that inside it has a black carbon rod, graphite rod. So best option is replace copper and make a conducting material like copper. This cell will keep on working and will have a certain voltage, 1 volt or 1.5 volt. That depends on position of these two metals in the series. Like zinc has this position and copper has this. So greater the difference, higher the voltage. Zinc and copper has this much difference, normally the voltage is 1.5. If you replace zinc with magnesium, you have increased the distance, so the voltage will be high, like it can go to 2 volt. So magnesium, and if it is copper here, the voltage can be 2. But as I said, easier option is replace the other electrode. You need only a conductor there. You need only something, a material where electrons can go, can pass through, so they start moving from negative terminal to positive. Remember, when this electrode is negative, it is anode in the electrochemical cell, because loss of electron occurs, and this is positive because there is no tendency to react. There are less electrons, lesser electron mean we term it as positive. So the best option is you need a reactive metal and you need a least reactive stuff, cheaper stuff, easier available, and that is carbon, the graphite. Okay, so electrode reaction you need to write. In case of magnesium, you will write down like this, that magnesium is going to the solution as magnesium ions, but leaving these electrons behind. Never dive these electrons there. In your equation they show as what? The electrodes basically are released at anode, but they stay behind and they move from negative to positive terminal, from high potential to low, and the bulb lights up. Okay, we need a suitable electrolyte. You use the word suitable electrolyte. That suppose this is a cell made up of magnesium and copper. Now electrolyte should not be silver nitrate, because if it is suppose silver nitrate, then silver is below copper. So copper will have a bit more tendency to replace and react with. As a result, this electrode may also become appreciably negative. So difference of potential will be less. The better it is that the electrolyte which is used at least is not in a competition with the less reactive metal. So we can use sodium chloride or ethanoic acid or citric acid juice or whatever. But remember, electrolytes cannot be the solutions like starch solution, or they cannot be a solution like glucose, or electrolytes cannot be a distilled water. Look at this. Everything seems to be fine here, but if it is starch solution, alcohol, distilled water, or any other non-electrolyte like glucose, then you need to be alarmed. This is not actually a cell working, because inside there should be an electrolyte. That is the reason in most cases you will find out in exhibitions that the students are showing that they have prepared electricity out of a potato or a lemon or orange, basically because they contain electrolytes. And a reactive metal, they have a zinc strip, a less reactive metal like copper, and when they connect these two together, normally they immerse these two into the lemon thing, and then join the terminal, join basically by using a wire. The more reactive metal zinc is going into that electrolyte of lemon as zinc ions, leaving the electron on the surface. Electrons start moving from this terminal to this. This is loss of electron, negative, positive. And for the bulb lights up, and they say that they produce electricity out of the lemon. Actually the role is of reactive metal, of least reactive metal, and of the lemon which contain the electrolyte. However, you can have an example like if it is both electrodes made up of same material, like iron iron, like copper copper, like magnesium magnesium, and inside everything seems to be fine, but you notice these electrodes made up of same material. It means both are reacting with the solution and going into the solution as ions, and both have actually same number of electrons left at their surface. As a result, there will be no difference of potential. So you cannot find the electrons running in and lighting up your thing. So there will be no working of the cell. Okay, and remember, electrolyte has a suitable concentration. Higher the concentration, it means more the reaction will take place. As a result, cell will use up quickly. So we use a suitable electrolyte concentration. But sometimes you have an electrolyte, you have a cell working, and somebody asks you that, okay, add bit more of the water. So the electrolyte become dilute. It means concentration become less, reaction of reactive metal get less. In that case, you will find out the voltage decreases, or at least the amount of the current that was produced at that time decreases, and the bulb is not getting brighter, rather it is getting dimmer. When you add distilled water into it, you decrease the concentration, bulb is getting dimmer. And if you increase the concentration, you will find out that increased concentration means quick reaction, and the bulb is getting bit brighter. Okay, because electrolyte is playing the role. How long the cell will work, it depends on the concentration of electrolyte, because after some time it will get exhausted and zinc cannot react with it. So you will find out that you need to replace the batteries. Okay, so the best thing is basically the cell works for certain days, the portable current it is. Okay, and the voltage depends on how much the difference of the potential is there. We use a suitable metal, because zinc is suitably reactive, it will pass some time. If you use a reactive metal, the reaction will be so fast, finishing off, not feasible, so we will not be able to use cell for long. The best options are normally, you will find out cells, and cells basically has, you will find out a simple cell like this. The casing of the cell basically is made up of zinc, and you will notice that this is one side as a positive terminal and a negative terminal, and you need to join the wires and you will find out the current moving. Okay, so this is simple cell, casing is of zinc, and if you take it off you will find out a carbon rod inside. Zinc is acting as a casing as well as a negative terminal, and inside there is graphite rod basically that is acting as an inert electrode. So electrons are generated at the zinc. Key behind an electrochemical cell is you should have a reactive metal. It reacts with the electrolyte inside, generates the electron, and those electrons which stays at its surface, they move to the positive terminal, the terminal where there are less electron, as there is a difference of potential. So cell will work only when the joining occurs of the two electrodes. Okay, so to make things simple, an electrochemical cell changes chemical energy to electrical energy when it carries out a chemical reaction that generates electrons, and the electrons which are generated You make them feasible by creating a difference of potential from high potential to low potential. They move, they'll keep on providing the energy until the electrolyte exhausts. And then you'll find out that you need to replace the batteries. So best options are a reactive metal, a least reactive metal, or a cheaper conductor like carbon. But you need to be careful looking at a cell. Look for a reactive metal, less reactive metal, a suitable electrolyte. It should not be starch or distilled water or anything else. Okay, and there must be difference in them. I mean, it cannot work like iron together. However, if it is even copper and silver, and you will find out they are so low in the reactivity, but even then the cell will work. If he asks you which is the negative terminal, you will look at your reactivity series. Copper is above, more reactive, silver is below, less reactive. So it means copper is going to the solution more, providing more ions there and leaving more electrons as compared to silver. Silver has less electron. So this terminal is more negative, more electron released. It means here copper is acting as anode, leaving the electrons, lots of electron behind as compared to silver. So you'll find out current start moving from negative terminal to positive terminal. Okay, so you'll show in this case. You need not to say this thing that these two are not feasible because they are so less reactive. You know that at least with copper and silver, copper will be the negative and the silver on the other hand should act as a positive electrode. It has more tendency to release electron as compared to silver. So electrochemical cells are a wonderful thing to use because they are portable current. They work for certain days, provide our appliances the energy, and then we replace them. They are cheaper option, easier they are because we are using not copper inside, the expensive one, rather the graphite. Electrical energy is produced from what? Chemical reactions. You carry out a reaction that generate basically lots of electrons, and these electrons need a pathway, and pathway you provide by joining them together, and difference of potential you create. Current move from high potential to low potential. Oxidation right here, anode, negative terminal, and reduction there, cathode. Cathode in this case is positive terminal. That's about electrochemical cell.